Alright, so continuing here with 6.4, and we're going to try out some more examples here with factoring. So, let's see here. When we're looking at these, start by the numbers again, and I realize that in every single one of these I can divide each of them by 3. I can take a 3 out of every single item. When I take a 3 out of every single item there, the 3's cancel out here. This right here reduces down to a 4, right? So I got a 4 there. And this reduces down to 5. Okay. Next up is x's. I want to take out any x's that are all the same. Well, I have an x cubed that I could take out of every single one of these, right? If I take an x cubed out of every single one of these, that means there's no more x's here. If I take out an x cubed, all I have left is an x squared. If I take out an x cubed here, all I have left is an x to the 4th. So all I have left over on the inside is an x to the 4th, because that's all that's there for the first term. Okay? And I still have in the second term a positive 4, and I have an x squared. And all that's left in the last term is a minus 5. Okay, perfect. Now I need to see if I can factor this in here, and surprisingly enough I can. And this one is tougher for you guys to see, but x to the 4th, I can rewrite that as something. I can rewrite that as x squared squared. And maybe if I rewrite this right here and put that in parentheses, maybe this makes things a little clearer. Now I know when you look at that, just looking at the item on the inside right now, I know when you look at that, you're sitting there and you're saying, alright, how does that help me? Let me explain how it helps you. Here's what we're going to do off in the corner. I'm going to say, we're going to substitute. I'm going to say that x squared equals a. The reason why I'm saying that is if we move back down here, now what I can do is I can rewrite this as a squared plus 4a minus 5. The reason I'm doing that is, can you think now, because this looks like a quadratic equation, can you think now of a number that when you multiply it together gives you negative 5, that also when you add it together gives you 4? I can, right? A positive 4 and, a positive 5 and a negative 1. 5 times negative 1 is negative 5. Positive 5 minus 1 is positive 4. So really you can factor this into a plus 5, this is what we have here, and a minus 1. Okay, so far so good. Remember, we still have that 3x cubed on the outside. Okay, so remember that we have that a plus 5, a minus 1. So we had up here a plus 5, right? And we had a, let me get down here, a minus 1, and we had a 3x cubed on the outside. Okay? But if you remember over here, I wrote down that x squared equals a. Right now, we have to resubstitute back in because I have two different variables here. So our final answer here will be 3x squared. This is x squared plus 5, right? And this is x squared minus 1. Now, I just got done telling you, oh sorry, it's cubed, not squared. I just got done telling you that that's your final answer, when really it's not. As much as you guys are going to hate me for this, this can actually still be taken down, factored even more. Why? Because it's subtraction, which means it can be difference of squares. I can rewrite a 1 as 1 squared. I can rewrite an x as x squared. So what that really means is this I can rewrite as x minus 1 according to difference of squares, and I can rewrite it as x plus 1. I also have this out in front, so I put that in. I have my x squared plus 5 out there, and I still have this 3x cubed. And I can't take this item down any farther right in here because it's positive, so there's no formulas to factor. So finally, after all of that, now that's factored. Let's take a look here at another one. They all have a 4, so let's take a 4 out of everything. All right, so I take a 4 out. It's the highest value I can take out of them. And they all have an x squared, so that leaves that one with a 4th power. Take out an x squared, that leaves that with just a 2. Take that out, there's nothing there. So I take out an x squared out of all of them. All right, I took out an x squared, leaving me with x to the 4th power still on the inside there, minus 2. That's an x squared left over because I only took 2 x's out and there were 4, and minus 8. All right, and just like the last problem, what you realize is that x to the 4th I can rewrite as x squared minus 2x squared minus 8. And right off to the side again, we'll say that x squared, if I can get this to write correctly, x squared equals a. So I'm going to resubstitute this in. So this is actually a squared minus 2a minus 8, right? So can you think of two numbers that multiply together to give you negative 8 that add to give you negative 2? Well, I can. Negative 4 and positive 2. So I can actually write this down as a minus 4. That's what we have right there. And I can write it down as a plus 2. Okay, and remember I still have that 4x squared out in front. Still that 4x squared out in front. So since we're running out of room, I'm going to have to erase this. So remember a minus 4 and a plus 2. So we have an a minus 4 and an a plus 2, right? And we said that we had a 4x squared still out in front. We also set up here from above that x squared we said was a. So let's substitute x squared back in. So I get x squared, all right, x squared minus 4 right there. And I get x squared plus 2. And I still have this out in front, the 4x squared. Now, this, if you realize it, 4, I can rewrite that as a difference of 2 squares. That's 2 squared. And x squared is obviously x. I can write that as x squared. So really I end up with an x minus 2 according to the difference of 2 squares. X minus 2. And I get x plus 2. And I have that x squared plus 2 behind it. The reason why that doesn't simplify anymore, it's supposed to be a 2. The reason why that doesn't simplify anymore is because it's an addition sign and we don't have an addition of 2 squares. But also don't forget that 4x squared out in front. If you have any other further questions, I hope these examples helped out. And if not, maybe we can get some more examples down here for you. But if you have any other further questions, please email me and please let me know. Thank you.